We recently had the opportunity to dive deep into a thermal paste alternative for CPU and eventually GPU cooling that uses carbon nanotubes literally grown in a forest-like structure surrounding a thin aluminum strip. This creates a highly thermally conductive pad-like solution. To learn about how it works and how it's made, we spoke with Jakob from Noctua, which is co-branding the solution, and with Matt from Carbice, which makes it. It got technical.
And so carbon nanotubes are a pure carbon material that it's an allotrope of carbon where you have carbon-carbon bonds basically wrapped into a tube. We take that material into a growth process. It's a vapor deposition growth process. And when the phase change material melts and it's under pressure and application, there's a wetting action to where the wax material, the phase change material, gets pumped out.
Let's dive into the science of how this particular carbon nanotube cooling solution works. Okay, so we have something pretty cool. This is a carbon nanotube thermal pad that Noctua is working with a company called Carbice on. And this is on an AM5 solution right now. I'm joined by Jakob from Noctua. You've joined a lot over the years. And by Matt from Carbice. It's pretty interesting where, we've seen a lot of pads over the years. So I've tested multiple of Romans. There have been some liquid metal pads over the years as well. What are the main upsides of going for this particular type of thermal pad as opposed to, pastes to start with?
Yeah, I would say that the key benefit of this pad is that it really further improves that low maintenance aspect to a level where we can say it's basically zero maintenance. The beauty of this pad is that it will improve its thermal performance over time through thermal cycling and then keep steady performance for years and years and years. Basically, we have no problems recommending using this pad for more than 10 years. Chances are it's going to outlive the device you put it on.
Before that, this video is brought to you by Montech and the 10 Micro ATX case. The 10 is launching for Montech's 10-year anniversary and goes heavy on the mesh ventilation with a fine mesh front, side panel, and even heavily ventilated rear exhaust for the case. The case is an open slate for fan positioning and airflow, and also advertises 9 power supply positions, 3 motherboard positions, and 7 GPU slots across modes, which makes the case highly reconfigurable, giving you the ability to build a unique micro ATX PC that gives more space than ITX, but doesn't take the footprint of ATX. Learn more at the link in the description below. Paste you can have pump out effect, it can also just dry. Over time, generally it gets worse. The interesting thing you guys were showing me, I guess, was this chart where there's sort of initially, I guess, out of the box, it sounds like this pad will perform technically worse, I guess, immediately out of the box versus a paste like for like. And then as it cycles in, so the blue line is the pad. As it cycles in, you reach parity and I guess eventually eclipse the performance of the paste.
Yeah, exactly. The improvement in thermal performance that the pad shows over time is only half of the equation. The other side of the equation that many people just don't have on the radar is that the thermal paste degrades over time due to pump out, dry out, and other degradation effects. So you should not only look at T0 performance, at those benchmarks that are usually done after 30 minutes of testing, 1 hour of testing. This only looks at the fraction of the complex picture that TIM performance actually is.
Right. What are the normal applications for you guys?
Yeah, so Carbice is a company that was spun out of Georgia Tech, out of a research professor's lab, Dr. Bartu Nicola. Our first initial commercial applications were in the satellite space, so we're in over 30 satellites. And as we mentioned earlier in the conversation, if you have a satellite up in space, you don't really have the opportunity to go up there and repaste your thermal interface
Very large
material.
ladder.
Yes, yeah. You have no room for degradation of your material. So that's really where we got our start. Now we're here and we're really excited to be working with Noctua and AMD, releasing our products.
That's right, you're in the 5800X3D anniversary edition, right?
Correct.
Yeah.
Yep.
You've got kind of an aluminum strip in the middle, and you were saying on the manufacturing side, you grow outward, right, for the bordering material on the aluminum. Can you walk me through the physical composition of the pad?
Yeah, so our material basically starts with standard household aluminum foil. Mm-hmm. It's a little bit thicker, so it's a very robust aluminum foil, but we take that material into a growth process. It's a vapor deposition growth process, so we take it into our chamber and we have a recipe that we run to where we grow forests of carbon nanotubes vertically off both sides of that aluminum foil. So you can think of this strong aluminum core with a forest of carbon nanotubes grown vertically off both sides. And so carbon nanotubes are a pure carbon material that it's an allotrope of carbon where you have carbon-carbon bonds basically wrapped into a tube. And one thing that's really unique about this material is extremely high thermal conductivity. So instances where it's been proven to be over 5,000 watt per meter Kelvin thermal conductivity in a tube. You don't get that same effective thermal conductivity in a forest, but it's really an ideal type of material to grow and to make a thermal interface material. And so as a final step in our process, we actually infiltrate or conformally coat the carbon nanotube forest with a phase change material. And so that's part of this activation and break-in process that we've been talking about, to where the performance gets better over time because that phase change material melts and enables the carbon nanotubes to wick in and wet the surface of the devices.
Is it regularly or actively going through the phase change process as you thermal cycle it, or is this kind of like a first application phase change and then it's stable at that point?
The material will continue to melt and re-solidify as it thermal cycles, but what's key about the initial activation process is that really the wetting process, when you first melt it, enables the carbon nanotubes to get pulled into contact with the surface. So once they're pulled into contact, they stay there, but that initial activation point is where you see the strongest decrease in your device temperatures or improvement in your device performance.
So internally, when you say pulled into contact, I mean, what does that look like? Is this like literally they're kind of standing up towards the cold plate, I guess, or what do you mean by?
Correct, yeah. So you can think of the forest kind of as the carbon nanotubes are all a little bit bunched up, almost like a bush or something a little bit more compact. And when the phase change material melts and it's under pressure and application, there's a wetting action to where the wax material, the phase change material, gets pumped out and the CNTs get pulled into contact. So the CNTs actually will extend into that surface contact.
Okay. And then Jakob, on the Noctua side, you were telling me that initially you guys weren't 100% sure on going this route. So what was the initial resistance or hesitation, I should say, and what changed your mind on it?
Yeah, absolutely. When Carbice first approached us, we ran our first tests. We went through that first activation phase that gave us around 1 Kelvin drop in temperatures. We were still not entirely convinced of the product, because we were looking at it from a similar perspective as most users look at thermal paste performance today, this short-term testing that I've mentioned before. And then it took us some time to actually realize the full potential of the product, wrapping our hand around the fact that you really need to look at it from a much more long-term perspective, and not just factor in the further improvements we saw cycling the pads further through a couple of hundreds and even a couple of thousands of cycles, but also keeping in mind that thermal paste degrades over time. Right. And this is when we realized how interesting this product is for PC users who just don't want to think about, should I go into replacing my thermal paste after 3 months, 6 months, 12 months? With this product, you just have the peace of mind that after a certain time, let's say typically maybe 6 to 12 months, you have reached an optimal performance level, and you will maintain that performance level pretty much indefinitely.
Okay. This I didn't ask before, but how's the endurance? If you were to, now I'm asking more from my perspective on the testing side, because there's some use cases for us, but like CPU cooler installation, removal, how does it fare under that kind of, that cycling, I guess? So the pad is definitely very easy to remove. It leaves hardly any residues. There can be a little bit of the polymer left on the CPU and on the cooler, but you can easily clean that off, for example, with our cleaning wipes. And we actually had a long discussion on whether we should advertise the product as being reusable or not. And ultimately we decided against it, despite the fact that actually if you're careful, maybe 7 out of 10, 8 out of 10 cases, you can reuse the pad without any measurable loss of performance. But there is that slight risk of
damaging the aluminum layer, kinking the aluminum layer, maybe some carbon nanotubes detaching from the material. And then we decided that the better way to approach it is that we're going to have an FAQ that explains precisely that and tells people if you want to reuse it, go for it. In many cases, it will be possible and you'll have perfect performance, but it's just not something that we can guarantee.
Okay,
that's why I decided against marketing it as reusable.
On the production side, so you were talking a little bit about how it's manufactured. So it's the foil and then you're growing out from the two sides. Is that foil suspended in something? Is it floating in a liquid?
It's just suspended in an open environment, essentially. So it's a sheet just sitting in a chamber, and then it's we control the gaseous nature of the environment, so it can be different compositions such as carbon gas that we pump into it, but it's just a floating sheet in a chamber. It's not in liquid, it's in gas.
Okay. The first time I heard of you guys, I think was probably the 5800 X2D announcement a couple days ago. How long have you been making some version of this pad?
So Carbice was founded in 2011 originally, while I was still in the research stage at Georgia Tech. We first started getting our commercial products into the satellite market in 2016 to 2018 timeframe. So we've been shipping products since that time frame and making it in a similar form factor, just slightly different variations. For the specific AMD AM4, AM5 product that we're launching with Noctua, and that's on the AMD device that you mentioned, that's more so been developed in the past 6 to 9 months, specifically engineered for that product.
What's the total thickness look like of the pad?
Yeah, the total thickness of this variety of the pad, this particular product, is 90 microns in thickness. So just if you want to talk about just general characteristics that differ from different carbon type pads that are currently on the market, one of the big advantages, which we mentioned earlier, is that you can actually go to extreme thicknesses or thinnesses such as 90 microns because of that strong aluminum core. You don't have to worry about the material tearing apart. It's very robust. It's not going to rip on you. So it enables a thin bond line. A couple other aspects which Jakob mentioned earlier is the polymer coating that we put on the carbon nanotubes enables a tackiness to it. So during the installation, it's truly a peel and stick solution. You peel off one side, you can actually stick it onto the device and peel off the other side of the release liner and make your configuration there.
Got it. Are there any sort of practical downsides in the PC DIY application, ignoring things, I guess, like outside of price characteristics, just strictly from a performance or usability standpoint?
I would say it's really only that initial thermal performance for the first couple of, depending on your usage, hours, days, maybe a few weeks, where you'll see like slightly higher temperatures typically than with a thermal paste. But other than that, I mainly see advantages. We already spoke about the long-term performance. That is, from my perspective, the key advantage. But I can also see this product catering to novice users who still feel unsure about how to best apply thermal paste, how much to apply, because this one, as Matt has mentioned, is just peel and stick. There's no question of dosage or how to apply it. I would also say there's a big benefit in like how easy it is to clean off. You don't have that like mess of thermal paste all around your socket, and especially with AM5, if you don't use a thermal paste card like we offer, that it creeps into the cutouts of the heat spreader. So yeah, except for the initial thermal performance, I think it has like a lot of advantages over thermal paste.
I don't think we've mentioned it on camera yet, but probably worth going over electrical conductivity.
The conformal polymer coating makes the contact surfaces electrically non-conductive before installation. On the edges of the pad, the aluminum layer is electrically conductive. So the key point is, from our perspective, that the pad is very easy and safe to apply. due to the contact surfaces being not electrically conductive, but mainly due to it being so tacky and sticky, so it doesn't slide around like other graphite pads. But even if it should, for whatever reason, if you drop it somewhere, the contact surfaces are safe, and it would only be in the unlikely scenario that you touch two current carrying components with the edge that you could actually shorten something out.
Pretty unlikely. Any reason to not put this on like a GPU or something? Because that's, people are going to want to do that. So.
You did a lot of GPU testing. The reason why we're focusing on the AM5 platform at the moment, initially at least, is that we have a very good understanding of the surface flatnesses, of the mounting pressures, especially with our own coolers. Whereas with the GPU, there is no a fixed standard in terms of mounting pressure.
Also, die size changes constantly.
Not in terms of surface flatness of the heat sinks. So if people just went out replacing their GPU pads or paste with the pad, it's very likely that in many cases they would see excellent results. And the benefit with GPUs in terms of pump out resistance versus pads, where pads pump out, versus paste, where paste pump out very quickly, that would be a huge benefit on GPUs, but it's just more challenging in the environment in terms of different parameters, changing parameters. That's why we're focusing on that.
Yeah, and one of the key aspects of the materials is our ability to control the thickness of it, and we can also control to some degree the compressibility. So, as Jakob mentioned, this product is optimized for the bond line thickness that you'd expect with a lidded AMD device and then the high performance Noctua cooler. And so we've minimized that bond line in this thickness to the minimum amount we need to maximize the thermal performance. For GPU type devices that have more extreme curvature, and especially on the bare die, our optimal product might be a thicker product or a different design to the actual product itself. So it would probably still work and give you pretty good results, but from our perspective, what we're planning to do is release specific products that are optimized for those different devices.
Right. The last sort of like technical one, I guess, I have for you is, so for this, talking about thermal cycling, can you guys just define for me, in terms of this chart, what to you constitutes a thermal cycle in this test?
So the testing parameters in this case were bringing in the load phase the pad above 60 degrees Celsius on both sides of the pad, and in the idle phase bringing it below 50 degrees Celsius on both sides of the pad. In our case, we ran pretty quick because we have a very good understanding about the temperature gradient, so that enables us to run relatively short cycles, 3 minutes on, 3 minutes off, something like that. When it comes to giving guidance to customers or reviewers, we're a little bit more conservative in terms of the time under tension or time without tension to make sure that customers are really hitting that tops and bottoms, even if, let's say, the heatsink is still saturated and takes some more time to cool off. So in this case, we would probably recommend something like a 5 minutes on, 3 minutes off or something like that.
Okay, got it.
Another important point that we should probably stress, though, is that it's not like you have to go through deliberate thermal cycling for this to happen. It's something that will also happen organically under use. It's just very difficult to collect that type of long-term data to predict exactly when you will see which sort of temperature drop if you are, I don't know, having one hour up, 2 hour down every 3 days. It gets very complicated and near impossible to test with a reasonable sample size. But the important message for users who may be concerned that it takes like deliberate thermal cycling for the thing to work, that's totally not the case. It will happen will happen organically. Just for us to collect data, it's better to have something like a fixed cycle that we can build on and trust on.
Yeah, you have to standardize it some way, but the product's designed to break in naturally in use.
Yeah, I mean, you'll hit 95C on the CPU from launching a game and compiling the shaders, so and then it'll come back down. So yeah. Last one, I guess. Do you have price and release date yet on the Noctua variation?
We target the release in September this year. Pricing is not going to be is not entirely finalized yet, but we're aiming for $24.90 USD and Euro price point.
When is the Noctua satellite collaboration coming? When are you going to put a brown and beige satellite in space? And where do
we
I point
first
my
need
telescope?
to change the carbon nanotube color from
Yeah,
black to
right,
brown.
right.
Then we'll start looking into the satellite.
Yes, okay. I look forward to that for Computex next year. I expect you'll have a satellite on display for me to show.
It will be our key focus to make that happen.
Excellent. Okay. Thank you, Jakob, for joining.
Thank you, Steve.
Thanks so
Matt,
much.
thank you.
Yeah, thank you.
And we'll see you all next time.